Hello students, this is Pallavi Karmat. Here are some of the example based on regular falsy method for homework. You can just practice them. Now today we will start with Newton-Raphson method. In this method, we locate an approximate real root of the given equation and improve its accuracy by an iterative process. So a Newton-Raphson method formula is given by x1 is equals to x naught minus f of x naught divided by f dash of x naught, provided f dash of x naught not equals to 0. So students, in this method also we use the fundamental property of a into, that is, we have to find the values of a and b such that f of a into f of b is less than 0, and we use this in the initial stage only. So consider the example. To find the real root of the equation x cube minus 2x minus 5 equals to 0, correct to 3 decimal places. So here we have to find the interval a and b where the real root of this equation lies. So consider the function f of x is x cube minus 2x minus 5. Now we have to try for various values of x. So let x is equals to 0. Put the value of x equals to 0 in the function. So x cube is 0 minus 2x is 0. So it will remain here with minus 5. So f of 0 is minus 5. Then similarly put the value of x as 1. X cube is 1 minus 2x is minus 2 and minus 5. Therefore, we obtain the value f of 1 is minus 6. And then similarly, you put the value of x is equals to 2. That is 2 cube minus 2 into 2 minus 5. And the answer is equals to 16. Now, see what is f of 0? F of 0 is minus 5 less than 0. F of 1 is minus 6 less than 0. F of 3 is minus 1 less than 0. F of 2 is minus 1 less than 0, and f of 3 equals to 16 greater than 0. So f of 2 is less than 0, f of 3 is greater than 0. So we have got here one positive value and negative value. Therefore we say that the real root lies in between the interval 2 and 3. Now how to consider x naught value? Because in the formula we have x1 is x naught minus f of x naught divided by f dash of x naught. So we have to consider one of the value of 2 or 3. So what x naught is to be considered? Now we see that value of f of 2 minus 1 is closer to 0 than f of 3, which is equals to 16, and therefore we consider this value as x naught. So we say that the real root will lie in the neighborhood of 2, and consider that x naught equals to 2. And therefore, now consider your function. In the formula, we say that x1 is x naught minus f of x naught divided by f dash of x naught. So we also require derivative of the given function. So our function is f of x equals to x cube minus 2x minus 5. Therefore its derivative denoted by f dash of x equals to x cube derivative 3x square minus 2x derivative minus 2 minus 5 derivative 0. Therefore f dash of x equals to 3x square minus 2. Therefore, let us start the first iteration x1. x1 equals to x naught. X naught value is 2 minus f of x naught. That is f of, put the value f of 2 and then divided by f dash of 2. Therefore, it is x1 equals to 2 minus 1 divided by 3 into 2 square minus 2, and the value is 2 minus of minus plus 1 divided by 3 into 2 square is 4. So 3 and 4 is 12. 12 minus 2 is 10. Therefore 2 plus 1 by 10, which is equals to 2.1. Now we are going to use this x1 value as the iteration value for the second one. So x2 equals to x1 minus f of x1 divided by f dash of x1. So we have to use the answer of the first step in the second iteration. So put the value of x as 2.1 in the function. So you should also calculate the value of the function at 2.1 and also calculate what will be the derivative of the function at 2.1. That is, in the formula it is x2 equals to 2.1 minus f of 2.1 divided by f dash of 2.1. That is, x2 equals to 2.1 minus, we have substituted the value of x as 2.1 in the function, that is 2.1 the whole cube minus 2 into 2.1 minus 5 divided by value of x as 2.1 in the derivative of the function. So it is 3 into 2.1 the whole square minus 2, and on simplification the answer is 2.0946. Therefore, you can compare your x1 and x2 value. x1 obtained is 2.1, x2 obtained is 2.0946. But the value asked is correct up to 3 decimal places. Hence, we go for one more iteration, x3. Now, here we have to find the value of the function at 2.946 and also value of the derivative of the function at 2.0946, that is x3 equals to 2.0946 minus, put the value of x as 2.0946 in the function. So 2.0946 the whole cube minus 2 into 2.0946 minus 5 divided by 3 into 2.0946 the whole square minus 2, and the value obtained here is 2.0946. Now you can compare x2 and x3. So x2 is 2.0946 and also x3. Hence we say the value up to correct 3 decimal places is 2.0946, or it is said the approximate root correct to 3 decimal places. It is rounded up 2.095. Now let us consider another example. To find a real root of the equation correct to 4 decimal places where the root lies near x equals to 0. So consider the function f of x is x raised to 4 plus 2x square minus 16x plus 5. And in this example, we are not locating where the root lies because they have already mentioned in the question as root lies near x equals to 0. So we consider directly x naught equals to 0. Now let us find the derivative of the function. So derivative of the function x raised to 4 derivative 4x cube plus 2x square derivative 4x minus 16x derivative minus 16 and 5 derivative constant 0. Therefore, f dash of x is 4x cube plus 4x minus 16. Now, we find what is value of the function at x equals to 0, that is put the value of x equals to 0 in the function. Therefore x raised to 4 is 0, 2x square is 0, minus 16x is also 0, hence we will remain only with 5, that is f of x naught equals to 5. Similarly, now we have to put x equals to 0 in the derivative of the functions, that is f dash of x is 4x cube plus 4x minus 16. So put here also x equals to 0. So 4x cube is 0 plus 4x is also 0. So here you will remain only with minus 16. That is f dash of x naught equals to minus 16. Hence now we use these values in the formulae, and the first iteration is given by x1 equals to x naught minus f of x naught divided by f dash of x naught, that is x naught 0 minus f of x naught 5 divided by f dash of x naught minus 16. So 0 minus of minus plus 5 by 16, and the value is 0.3125. Therefore x1 obtained is 0.3125. Now we have to use this value in the second iteration. So x2 is given by x1 minus f of x1 divided by f dash of x1. So before to this, we have to put the value of x as 2.0312 in the function and also in its derivative, and calculate what are the values. So here the value is x2 equals to x1. x1 is 0.3125 minus f of x1. So value of the function at 0.3125 obtained is 0.2048, and value of the function in the derivative obtained is minus 14.628. So minus of minus positive, and on simplification we are obtaining the value as x2 equals to 0.3265. So you can compare the values x1 and x2. x1 is 0.3125 and x2 is 0.3265, where we are getting the value only correct up to one decimal places, 0.3, as we have to go for one more iteration. Now we can go for next iteration x3, and in x3 we are going to use the value of x2. So again here also we find the value of the function at 0.326y, and also f dash value at 0.3265, and then substitute in the formula. So x3 equals to x2, that is 0.3265 minus f of x2, that is 0.00057 divided by f dash of x2, and the value obtained is minus 14.5548. This is on simplification 0.3265. So x3 is 0.3265. Now you can compare x2 and x3. x2 is 0.3265 and also is your x3. Therefore, the value is correct up to 3 decimal places, or it is also correct up to 4 decimal place, that is x3 is 0.3265 and x2 is also 0.3265. Hence we conclude that the approximate real root of the equation correct to 4 decimal places is 0.3265. Okay, now let us consider one more example. Find cube root of 37 correct to 3 decimal places. Therefore, let us consider x is equals to cube root of 37. That is x cube equals to 37, or x cube minus 37 equals to 0, and let us consider this is equals to f of x, that is f of x equals to x cube minus 37. And now we have to locate our root for this example. So take the various values of x. x equals to 0, x equals to 1, 2, 3, and so on. So let us see what will be value of the function at x equals to 0. If you put x equals to 0, that x cube equals to 0. So you will remain with minus 37. Now put x equals to 1. 1 cube. 1 cube minus 37. That is equals to minus 36. Again a negative value. Now put x is equals to 2. So 2 cube that is 8, 8 minus 37, which is again a negative value. Now put x is equals to 3. So what we have here, x is equals to 3 implies x cube. So 3 cube, 27, 27 minus 37, which is equals to minus 10 less than 0. Now try for x equals to 4. So 4 cube minus 37, and the value is equals to 27. Now we just observe that f of 3 is minus 10 less than 0 and f of 4 is 27 greater than 0. So we have one of the value is negative and another value is positive. Therefore we say that the root lies between 3 and 4. So now how to locate our x naught? So we have to see which value is closer to 0. So according to the observation, minus 10 is closer to 0 than 27. Therefore, we say that the root lies in the neighborhood of 3, and we take let x naught equals to 3 be the initial approximation, and we also have to find the derivative of the function. So f of x is x cube minus 37. Therefore, f dash of x derivative x cube is 3x square and derivative of constant is 0. Therefore, f dash of x is 3x square. Now, with this data, we go for the first approximation, which is given by x1 equals to x naught minus f of x naught divided by f dash of x naught. Therefore, we have calculated already what is f of x naught, that is f of 3 equals to minus 10, and then we have to calculate what will be f dash of 3. So that is put the value of x as 3 in f dash of x. So that is 3 into x square. X is 3 square again. So 3 into 3 square. So this value we have to put in the formula, that is x1 equals to 3 minus of 10 divided by 3 into 3 square. And on simplification the answer is 3.3704. So now this x1 value we will use to find the value of x2. Therefore, again we have to find value of the function at x equals to 3.3704 and also at its derivative. Therefore, x2 equals to 3.3704 minus f of 3.3704 divided by f dash of 3.3704, that is 3.3704 minus, put the value of x in the function, which is x cube minus 37. So 3.3704 the whole cube minus 37 divided by 3x square, 3 into 3.3704 the whole square, and the answer is x2 equals to 3.3327. Now you can compare your x1 and x2. So x1 is 3.3704, x2 is 3.327. Therefore, we need to go for one more iteration to get the desired accuracy. So make use of the value of x2 in the x3. So x3 is given by 3.3327 minus, put the value of x2 in the function and also in its derivative. Then that is 3.3327 minus, function is x cube minus 37, put the value, and then derivative is 3x square put the value, and on simplification we have it as 3.3322. Now you can compare an x2 and x3. So I'm comparing x2 and x3. The value are correct up to only 3 decimal places, that is 3.332. But in the question is also mentioned as find the value up to correct 3 decimal places. Therefore, what we can conclude here, from x2 and x3 only we are obtaining the value correct up to 3 decimal places, that is 3.332. Hence, we say the approximate root of the given equation is 3.332. Okay, so now let us consider one more example to find the real root of the equation x into e raised to x minus 2 equals to 0, correct to 3 decimal places. So write down f of x equals to x into e raised to x minus 2. So now we have to locate a root for various values of x. Put x equals to 0. So x is 0, 0 into e raised to 0, that is 0 minus 2. Hence, f of 0 is minus 2, which is a negative value less than 0. Now try for f of 1. So f of 1, put x is equals to 1, then e raised to 1, then minus 2. And the value obtained is 0.7183. So f of 0 is less than 0 and f of 1 is greater than 0. Hence we say that the root lies between 0 and 1. Now we have to consider x naught. So which value is to be considered for x naught? Either 1 or 0. So see, f of 0 is minus 2. F of 1 is 0.7183. So f of 0 is closer to 0 or f of 1 is closer to 0. It is obviously 1. So 0.7183 is closer to 0 than minus 2. Therefore, we consider x naught equals to 1. So we also require to find the derivative of the function. So f dash of x. Now the function is x into e raised to x minus 2. Here we have to use the product rule for differentiation. So x is kept as it is. Derivative of e raised to x is e raised to x plus e raised to x is kept as it is and derivative of x is 1. Therefore e raised to x is common. We get the value as f dash of x equals to e raised to x into x plus 1. Now we have to find the value of the function at x naught and also value of derivative of the function at x naught, that is x1 is given by x naught 1 minus f of x naught, that is f of 1 divided by f dash of x naught, that is f dash of 1. Therefore x1 equals to 1 minus 0.1 there is a printing mistake, okay, that is 0.7183 divided by what is the derivative? Derivative is e raised to x into x plus 1. So put the value of x in this. So e raised to 1 and x is again 1, 1 plus 1 is 2. So this on simplification the value of x1 is 0.8679. So now use this x1 value to calculate x2. So again we have to find the value of the function at x2 and also the value of derivative of the function. That is x2 is given by 0.8679 minus f of 0.8679 divided by f dash of 0.8679, which is given by 0.8679 minus put the value of x in the function divided by put the value of x in its derivative. Therefore, the function is x into e raised to x minus 2. Therefore, x is 0.8679 into e raised to 0.8679 minus 2 divided by e raised to x. So e raised to 0.8679 into x plus 1. X is 0.8679 plus 1. So on simplification, we obtain the value as 0.8528. Compare your x1 and x2. So x1 is 0.8679 and x2 is 0.8528. So we have to go for one more iteration to get the desired accuracy. Go for x3. Similarly, we have to use the x2 value to obtain x3. Therefore, x3 calculated value is 0.8526. Now you can compare your x3 and x2. So x2 is 0.8528 and x3 is 0.8526. So the values are correct up to 3 decimal places. So hence we conclude that the value correct up to 3 decimal places is 0.852 8.26. Now there is one more iteration done here, that is for x3, and x3 obtained is 0.8526. So when comparing x3 and x2, we say the values up to 3 decimal places is 0.852 and the values correct up to 4 decimals is 0.8526. So hence we say the required approximate real root correct to 3 decimal places is 0.853. Here, when we obtain the value correct up to 3 decimal places at x3 itself, we can also conclude. So it is not required to find x4. x4 we will find if the question is given as find the value correct up to 4 decimal places. Otherwise, we can find or we can stop the iteration at x3 itself.